We will now discuss the solution of a problem related to the class equation from the section group theory, broadly from the algebra section. This question has appeared in the CSIR National Eligibility Test held on 16th September 2022. And this question is from part C, that is multiple select question, bearing number 389. The given question is, which of the following are class equations for a finite group? Which of the following are class equations for a finite group? The first one is this one, for a group of order 39, most probably. The second option is for a group of order 14, probably. The third option is a group of order 21, probably. The fourth one is the class equation, probably for a group of order 15. So which of the following are class equations? You have to support them. Which of them is true? We will now discuss the solution of this problem in detail. Right. Before entering into the discussion of the given question, let us get some familiarization for the material on class equation. For that, let G be a finite group, and if the order of G is the product of two primes P and Q, where P less than Q and P divides Q minus 1, then the group G is isomorphic to a cyclic group of order PQ, or G is isomorphic to a non-abelian group. Order of G is the product of two primes P and Q, where P less than Q, P divides Q minus 1. Then the group G is isomorphic to ZPQ, or G is isomorphic to a non-abelian group. The second result what we have, if order of G is equal to the product of two primes where P less than Q and P does not divide Q minus 1, then G is isomorphic to ZPQ. That means G is necessarily a cyclic group. Agreed. That is, with these properties, that is the order is PQ, P less than Q, P and Q are prime numbers, P does not divide Q minus 1, then there is a unique cyclic group of order PQ with these conditions. Right. If G is a finite abelian group of order n, if it is a finite abelian group of order n, then its class equation is 1 plus 1 plus etc. plus 1 n times, that is equal to n. If it is a finite abelian group, the ZG is whole of the G. For that reason, this is the class equation that you are getting. If G is a non-abelian group and the order of G is the product of two primes P and Q, P less than Q, P divides Q minus 1, that is the first case. And if it is non-abelian, with these properties, then its class equation is 1 plus P plus P plus P plus P Q minus 1 by P times plus Q plus Q plus Q P minus 1 times. Okay, you have to remember, this is very important. You have to remember. Right. Now, we get into the discussion of the given question. Which of the following are class equations for a finite group? We are given the four equations here. So 1, 2, 3 and 4. Now, the argument goes like this. It is known that the class equation of a finite abelian group of order n is 1 plus 1 plus 1 all ones n times, that is n. And if we look at these above 4 equations, none of them is 1 plus 1 plus 1 plus 1, etc. So, no group of the above class equation is abelian. Had it been abelian, the class equation would have been all ones. It is not so. Therefore, no group of the above class is abelian. That means these might be perhaps these might be the class equations of non-abelian groups. So that is, the given class equations are the class equations of non-abelian groups. That's the argument what we have put forth. Now let's get into the first one. 1 plus 3 plus 3 plus 3 4 times plus 13 plus 13 2 times is equal to 39. Right. Now let's take the 39. So we recall already known result, that is here, and then the class equation of the G is this one. We remember. Now let's take the 39. It's a non-abelian group G, and the order of G is 39, is a product of 2 primes 3 into 13, 3 less than 13, 3 divides 13 minus 1. That means in this, P is 3, Q is 13. P is 3, Q is 13. It's a non-abelian group of order G. Therefore, its class equation will be 1 plus 3 plus 3 plus 3. That is P plus P plus P. How many times? Q minus 1 by P times. That means 13 minus 1 by 3, 4 times. And Q plus Q plus Q, P minus 1 times. That is 13 plus 13, 3 minus 1, that is 2 times. So yes, it is the class equation of a non-abelian group of order 13. Therefore, the option 1 is true. We have to find out those options which are true. So, option 1 is true, is one result. Right, let's move to the second. We have already seen option 1 is true. The class, this is the option 2 for a 14, for a group of order 14. Now we have a non-abelian group of group G of order 14. This is not abelian. If had it been abelian, 1 plus 1 plus 1 would have been there. It is not. Therefore, for that reason, we have a non-abelian group G of order 14. And note that here, order of ZG, the center of G, order of ZG, will tell you the number of ones in the class equation. The number of ones in the class equation will tell you the order of ZG. How many ones are there in this class equation? 2. So order of ZG is 2. And we remember this result, let G be a finite group, ZG be its center. If G by ZG is cyclic, then G is abelian. If G by ZG, that is this quotient group, is cyclic, then G will be abelian. Now order of G by ZG is equal to order of G by order of ZG is equal to order of G is 14 by order of ZG is 2, that is 7 a prime. A group of prime order is cyclic, therefore G by ZG is cyclic. Apply this result. G by ZG is cyclic, then it implies G is abelian. So G is abelian. This is a contradiction since G is non-abelian. If G is abelian, we would have got all ones. It is not. Therefore, G is non-abelian. So this is a contradiction. So that means, therefore, the given class equation is not a class equation of a group of order 14. It is not. It is not. A non-abelian group of order 14 will not have this one because we got this result. So this tells you the option 2 is not true. We have already proved option 1 is true. So note, what is the class equation of a non-abelian group of order 14, sir? Then the class equation is 1 plus 2 plus 2 plus 2 plus 7. 14 is 2 into 7. P is 2. Q is 7. And P divides Q minus 1. 2 divides 7 minus 1. So apply. And the class equation is ready made there. Yes. So the class equation of a non-abelian group of order 14, the class equation is 1 plus 3 2's and 1 7. That is 14. Let's move to the third option. So we have already seen option 1 is true. 1 plus 3 plus 3 plus 7 plus 7 is equal to 21. Right, we have that result, that famous result. So we have non-abelian group G. Order G is 3 into 7. P is 3, Q is 7. 3 less than 7, 3 divides 7 minus 1. Then this is the class equation. Then the class equation of G is 1 plus P plus how many times? Q minus 1 by P times. That is 3 plus 3, 7 minus 1 by 3, 2 times, 3 plus 3. And Q will occur 3 minus 1, that is 2 times, that is 7 plus 7. So the above one, it is the class equation of a non-abelian group of order 21. Therefore, option 3 is true. So 2 options are true so far. Right, we have come to the last option, that is option 4. That is a group of order 15 having this kind of class equation. Is there such a class equation for a group of order 15? I tell you that this cannot be the class equation of a group of order 15. Why? Every group of order 15 is cyclic. It's a very well-known result. Every cyclic group is abelian. If it is abelian, its class equation is 1 plus 1 plus 1 15 times. Therefore, this cannot be the class equation of a group of order 15. Therefore, this option 4 is also not true. But anyway, we need some argument. Therefore, we write down this way. We have a group G. Its order G is 3 into 5, P into Q, P less than Q, P does not divide Q minus 1. Right. Then G is isomorphic to Z15. Z15 is cyclic. That means G is isomorphic to a cyclic group of order 15. That is G is cyclic. Every cyclic group is abelian. G is abelian. Therefore, its class equation must be 1 plus 1 plus 1 plus 1 15 times. So therefore, the given class the class equation of a group of G of order 15 will be this one. Therefore, the given class equation is not the class equation of a group of order 15. Therefore, the option 4 is not true. So far, we have proved option 1 and option 3 are true, and we have to identify those options which are true. So therefore, the answer to this question is options 1 and 3. That is the detailed discussion of the solution of the problem, and I am sure that you have understood the solutions of this problem on the class equation. I wish you all the best. Thank you.